Okay, so if you skip to 25, in order to work with 25, we're going to use Heron's formula. And so with Heron's formula, we need to know the value of S. So S is equal to A plus B plus C divided by 2. And so they tell us in number 25 that A is 4, B is 4, and C is 2. So that means S is going to be equal to 5. Well, I don't know where 5 came from. 4 plus 2 divided by 2. So this is 8 plus 2 is 10, and 10 divided by 2 is going to give me 5. There's my 5. And so that means the area of my triangle is going to be the square root of S, which is 5, times S minus A, 5 minus 4, S minus B, 5 minus 4, and S minus C, 5 minus 2. So I have my area is equal to the square root of 5 times 1 times 1 times 3, which is going to give me the square root of 15 feet squared. And skip to 31. It's a little bit of a twist on an otherwise common problem. So we have this triangle, we have A, we have B, we have C. We are told that this side is 8 and this side is 13. We're told this angle is 35 degrees and this angle is 15 degrees. And we have to solve our triangle. So in order to do that, I'm going to need to know this angle. So I take 150 and I subtract 15, or 180 and I subtract 15 and 35, and that's going to give me 50. So 180 minus 50 is going to give me 130 degrees. And to solve for C, I'm going to use the law of cosines. So I have C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of 130. And so I have C squared is equal to 233 minus 208 times the cosine of 130. And I'm going to take the square root of all of that. And I'll let my calculator do all of that legwork. So this gives me C is approximately equal to 19. And then, or 19.1 since we round off to the nearest tenth. And then from here, I'm going to use the law of sines to solve for my missing angles. So I need angle A, and I need angle B. So to do that, I'm going to take my 19.1 over the sine of 130 and set it equal to 13 over the sine of A. And then when I cross multiply, just like I was doing before in numbers 3 and 5, I'm going to end up with the sine of A is equal to 13 times the sine of 130 over 19.1. And I take the inverse sine of all of that, and it's going to give me the measure of angle A to be approximately 31 degrees because my instructions say to round off to the nearest degree. And so to find the measure of angle B, I'm going to subtract from 180 the measure of angle C and the measure of angle A. So this gives me 50 minus 31 is going to give me 19 degrees. Okay, skip over to number 39. I heard that some of y'all were struggling with your bearings from the other day, so we're going to work an example that involves the bearings. So 2 ships leave a harbor at the same time. So I have a harbor, and I have 2 ships that leave at the same time. One ship travels on a bearing of south 12 degrees west. So if my bearing is here, so here's north, here's south, here's west, here's east. I'm moving in the wrong direction, but it'll still work. So I'm at south 12 degrees west. So what that means is I'm heading in this direction, and my angle is always on the north-south line. And I'm traveling at 14 miles per hour. And then the other ship travels on a bearing of north 75 degrees east. And we are traveling at 10 miles per hour. How far apart will the ships be after 3 hours? So what I know that this is 90. So I have 12 plus 90 is going to give me 102. And then this angle here is going to be 15 degrees because 90 minus 75 gives me 15. And this is 90. So I have 12 plus 90 plus 15. So the measure of this whole angle here is 117 degrees. And then what we want to know is if I draw in this side here, then that's how far apart my ships are going to be after 3 hours. So what I need to know is, so if I clean this up a little bit and draw a triangle that is a little easier to look at, I need to know this length. I know that this angle is 117 degrees. What I know is that the length from the harbor to the first ship is 14 times 3, because if I'm traveling at 14 miles per hour for 3 hours, then I have gone 42 miles. And then from the harbor to the other ship is 10 miles per hour for 3 hours. So this is 30. So my picture isn't drawn to scale, but that's neither here nor there. So what I do is I use the law of cosines. So this is going to be x squared is equal to 30 squared plus 42 squared minus 2 times 30 times 42 times the cosine of 117. And then to solve for x, I'm going to take the square root of all of that. So I have 30 squared plus 42 squared, and this gives me 2664 minus 2520 times the cosine of 117. And I'm just going to let my calculator do all of that work. So, and it tells us to round off to the nearest tenth of mile. So we're going to be approximately equal to the square root of 2664 minus 2520 cosine of 117. And this gives me about 61.7 miles apart in 3 hours. Okay, and number 41. We have find the distance across the lake from A to C. So we have this triangle that we're looking at here. We have A, we have B, we have C. This angle is 80 degrees. This is 140. And this is 160. And so you need to find A to C. And so you use the law of cosine solving for this side.